G'day, everyone. Welcome back to another Toolbox Tech Talk. You were probably expecting DJ Glenmo with all his bling on, but no, he's not available today, so it's just me. But it's going to be another special one. And today I've got a very special guest all the way from Austria, David Himmelfreund-Pointner. He's the product manager at MyPV. Now, this is a company that I've known for a long time. I've met one of the founders, Gerhard Rempler. He even came to my Master Smart Energy Lab many years ago and introduced me to some of their really interesting products. So I'll just bring David on back, and g'day, David.
Yeah, hello. Nice to meet you. Thanks for the invitation.
No worries. And thanks for getting up early. I know the time zones don't really work for us. We're on the other side of the world.
Yes, there's quite some time delay in between. That's right. I mean, here it's like 8 o'clock in the morning, but that's totally fine. I guess you're already having a long day over there.
Yeah, it's what we call in Australia beer o'clock.
I see. Sounds good.
It's probably coffee o'clock at your end.
Yes, right. Too soon for beer, little bit.
Too soon, yeah. Well, David, maybe just to kick things off for the viewers, maybe you could tell us a bit about MyPV and how you would summarize your product and your company's philosophy, considering the kind of broader solar energy landscape.
Yeah, sure. I mean, what we do is PV heating in many different ways. Actually, the founders of MyPV are doing this since more than 10 years, I think about 12 or 13 years now. And they have solution for various kind of applications, like if it's AC connected or it's completely off-grid systems, to only use really the DC power from panels, from PV modules directly for heating. We are really flexible here to make different solutions. So whatever you want to do with PV heating, we're going to have a good solution for that.
I think some of your innovations grew out of necessity. I remember Gerhard telling me he was really into hiking, and up in the alpine areas, some of those lodges don't have mains power, and they were running on Sunny Island inverter, and they just didn't have a capacity for an AC water heater. And he goes, I know how to solve this problem.
Yes, exactly. I mean, there is also a nice video I could show you afterwards where you can see as you said.
That's cool. So you make quite a range of products. I've here at the Smart Energy Lab been quite familiar with some of the direct DC units like the SC20 that's now been superseded, and also the AC Thor single phase and AC Thor 9S. But I see you've got this new product called Sol.Thor with a little dot in the middle there, which is interesting. I don't know how to type that. What is the Sol.Thor?
The Sol.Thor is a DC power manager. So you plug in panels, up to 2 strings to the Sol.Thor, and then you can make an off-grid PV heating system.
Cool. Now, I think you've got some slides you can show us a little bit about how the Sol.Thor works.
Yes, that's right. Let's have a look into. So actually this is how this Sol.Thor looks. It's a DC power manager. It's not an inverter. It's really just a DC power manager. So as you can see here, DC strings are directly connected to the Sol.Thor, and then the Sol.Thor is actually connected to immersion heaters or to warm water boilers to make off-grid heating applications.
Cool. So it's got an on-screen display showing you real-time power. I love the color display. It's very similar to the AC Thor 9S.
Yes, that's right.
Model. Yeah. Cool.
I mean, of course, you can set all the settings here on the display, but you have the option to connect it to the internet, to the cloud, and do everything remotely as well to see, okay, is it heating? How warm is the boiler? Do you want to change some settings? This is possible here and, of course, in the cloud. But this is fully optional, of course, as the AC connection is optional as well to back up the heating source, actually. Yes.
Right. So it's got 2 solar inputs. So for 2 strings of panels, do they need to be the same number of panels? Is there 1 MPPT or is there 2?
Yes, there is 1 MPPT.
Okay, so you just parallel 2 identical strings into the unit. What was the maximum DC input power?
Up to 10 panels, actually around about 4.5 kilowatt peak. Actually, we have an own tool to just make sure that your panels are not like being too strong. Okay, give me another try how to explain. Usually I'm explaining in German, so English is not that familiar for me, to be honest. I mean, what I'm trying to say is we can use these classical panels with like 450 watts, up to 10 piece of them. But we also have a special tool where you can like give all the details from your panels, and then you're getting a green light or a red light if this is fine for the Soltor. Yeah.
So this is a software tool to do a design.
Yes, right. You just need to give in all the data of the panels, and then how many you want to connect of them, and then you see, okay, this is fine, or no, this is maybe too much.
So I read the data sheet before we started this chat, and I noticed that it's got a maximum input current of 26 amps. Now, is that total? So not per input?
Yes, right. That's total. So 2 times 13 or 1 time like 26. Yes.
All right. So you can put high current into just one input, more than 13 amps into one input.
What do you mean?
Well, I've got an actual scenario here. We've got some utility panels, and they put out 18 amps. We've only got 4 of them, but I was thinking because the Solthor has got such a wide MPPT range from like 30 volts to 220, I think, even 4 panels would work, but it's quite high current. It's 18 amps IMP.
Yeah, so the current is actually limited by the Soltor itself, so it's no problem when the current is higher, but it's important to like keep in the range of the voltage of, as you say, the 230 watts maximum.
Right. So I can connect panels with 18 amps. I'm below the 26 amp maximum. I'll only use one input though.
Yes, right.
Yeah. Well, that's really interesting because utility panels, they're huge and they're quite difficult to match to inverters often because residential inverters generally have a rather low maximum current input, more like 15 to 20 amps. So this is a big plus. Now, you mentioned that the Solthor also can take AC. What do you mean by that? Have you got a slide to show us how that works?
That's right, of course. Let's have a look on the slide here. Here you can see the DC plugs, but there's also, as you said, an AC connection. Maybe we use this slide right here. As you can see, you can just plug in normal immersion heaters or boilers, and you have, of course, 2 options to giving power to the Soltor. Option number 1, of course, is here the DC connection. And this is actually all the Soltor needs for working. And optional is here to connect it to AC, just to have a backup power when there's not enough PV, electricity or energy. Then you can connect it to AC and make sure that you will always have like enough warm water.
How does it know if I have enough warm water?
Pardon?
How would it know that I've got enough hot water? Is it got
Oh,
a thermos?
therefore you just need a temperature sensor.
Hmm.
Yeah, and then actually you can set like 40 or 50 degrees. You don't want to get under this temperature, and when you would come under that temperature with DC power, then we just use AC.
Just like the AC Thor, which has a thermocouple that measures the temperature in the tank. So this does the same, and you can set the parameters, like you say, minimum, let's say 6 degrees, and if it drops below that and the sun's gone down, it's going to be using AC power.
Yes, right.
Excellent. Now, you also said that you can use it for heating not just a hot water system, but also like a boiler. Has it got two outputs you got for heating?
Yes, there are two outputs. As you can see here on the right side, you can like use these two outputs. You can use it for, I don't know how it's called in English, Schichtladung. So to at first heat up the upper one, and then like the immersion heater on the bottom. That's just good for taking out the hot water on top first, and then yeah, use it here on the bottom.
Yeah, we would call that top element a boost. Uh, so you just want to make sure you've always got a little bit of hot water and let the solar do the bulk of it down the bottom. Yeah, cool. So that top element can be AC, well, one of the outputs can be AC or DC.
Yes, that's right. So this is the immersion heater which has a priority number one because it's on top, and this one can also like be powered by AC, and this one here will only be powered by DC because we always want to keep this storage capacity for the moment we're having DC power.
Now, I can see the benefits for off-grid installations. In fact, we're doing installation here with the Solthor, I believe, and it's for a home with a modest size system. They've got a 5 kilowatt inverter. That 5 kilowatt inverter, if it was to be using its AC power to heat water, would have nothing left really to run the home. But with the Solthor, they can put 4 extra panels on, these big ones, heat with DC, and still have all of the inverter power available to run their home. So it extends your reach in terms of the services that you can offer with a relatively small system.
Yes, that's right.
Yeah, it's really clever. Maybe I'll just kind of give a bit of an Australian perspective too. I think I mentioned this before we started recording, is that a lot of Australian customers, even on grid, are limited by inverter capacity. So the utility will often limit them to 5 kilowatts for single phase, maybe a little bit more with export limiting. But the average system size in Australia is around about 8 kilowatts now. So people want big systems. And so they're being constrained by the electricity supply authorities, constraining how much inverter power they can have. But the Solthor solves this problem because it's not AC. There's no limit.
Yeah.
Yeah, it's really cool. Did you have some other slides you want to show us?
Let's see what we have here. Of course, some more technical details here. The range of the panels. There's also like a certification IP54, which just means that this device can be installed outside as well. So it's fine with dust and with like water. Of course, we recommend not putting it directly like in the sun. It's gonna get very hot, which is not optimal, of course. But actually, it's made for installation outside as well. Yeah.
Oh, I didn't notice that. That's a change from the AC Thors, which are only like IP30, I
Yes,
think.
that's right. That's the first time we are using some kind of certification. And usually our devices always have been like inside the house. But yeah, here it's a little bit different. Also made like for this off-grid yeah, application because when you are talking about off-grid, it's often the case that you do not have so much space inside, or you just haven't any space inside, but you want to do some heating applications. Yeah.
Yeah. Wow. That's a really good move.
Okay. What else do we have here? Here is just the explanation of what it means exactly, like IP5, dust and water sprayed from all directions.
Yeah, that's a pretty common rating for inverters too. You just don't want to have high pressure jets hosing your inverter, so or your Sol Thor.
Yeah, that's correct. Yeah, that's the
Right.
video.
So it's actually relatively small too. Like I'm used to the size of AC inverters, which often weigh 20 kilos, and they're 400 or 500 mils wide. This unit it's only like 150 mils wide, even
Yeah, I
smaller.
would say it's as big as my head, more
Yeah,
or less.
yeah.
But
It's,
I mean, I just have one device here, but it's still in original package. So actually, the size is about this with
oh
the
yeah, that's a good
with the
comparison. Yeah,
package.
yeah, yeah. Right. That's very compact.
Yeah, it's a bit bigger as the AC Tor here in the back.
Yeah, yeah. Now, can I see an antenna connection, or am I imagining that?
Yes, here is a Wi-Fi antenna.
Really?
Yes, yeah,
Right. So we don't have to do Ethernet like we do with the AC Thor.
that's right. Yeah,
Wow. Now, I think that opens up the conversation around remote monitoring. One of the things I love about our AC Thors is we've got them on buildings which are not local, but we can control the water heating just through the cloud. That's a really cool service. So using My PV Cloud.
yeah. The cloud is optional and for free, so everybody can use it. You just need to like get it connected.
Yeah, we've got one on a community building with sleeps like 20 people, and when there's no one there, we just let it use surplus PV only. But when people are coming and the weather's not good, we can remotely turn on the electric boost and make
Yeah,
sure the water's hot, and I don't have to go there.
yeah, that's fine.
Yeah, yeah, it's really
That's
cool.
fine. What
So
else
it
do we
also
have
has a LAN
here?
option as well. I see you've got a LAN port.
Yes, yeah, yeah, yeah. Right.
Yep. Now with RS485, what's the purpose of that?
Actually, I'm not sure. I think this is not used very often. I think it's just interesting then when you want to use any other kind of management or like to make it heat. Do you know what I mean? Maybe when you have any kind of energy management system, and
Yeah,
then you
so
want to like control it with any other kind of control source.
is it using Modbus?
Yes.
Oh, very easy then. So you publish the Modbus register, and then people can integrate with their building management system or energy management system.
Yeah,
Yeah,
you
that's
can
cool.
also use like an API to get it heating. Yeah. For example, you can also use dynamical tariffs from the grid, and then we will just heat when the prices are at the lowest.
You're blowing my mind, really. So you've got an API, and then you can link that to
Okay, you
dynamic
didn't know
tariffs?
that. I
No.
thought you maybe have heard of it. Yeah, that's right. So the cloud connection makes it possible to, yeah, connect it to the DTO, the MyPV DTO, which means Dynamic Tariff Optimizer. And then you have quite some options to configure that. You can like set a maximum price. Under that price, you always want to heat, but you can always also use different ways when you want to use the cheapest prices of the day. Yeah.
Well, it'll be interesting with the Australian market. We have a few electricity retailers that have dynamic pricing. So that means you've got access to the wholesale pricing in real time. But the problem is you need to be aware what that pricing time is. Whereas using an API, you can automate that. So when the price drops low, you can heat water. When it goes high, stop.
Yeah. So actually, we are doing everything it needs. You just need to configure it once, and yeah,
Yeah, it's cool.
basically. Yeah. Here is a list of all the technical details. Like, as we mentioned, here the maximum power from 0 to 2600 watts output. Also here the voltage range from 30 to 230 volts. Two parallel strings possible with this MC4 connectors as well. And yeah, as you have asked before, like it's current limited.
Now, I'm just looking at your website at the moment too, and I noticed that you've got a MyPV Wi-Fi meter. Does that get utilized at all with the Solthor system?
No.
No.
I mean, usually no. There is an application, yes, just to use the Wi-Fi meter as a meter to measure any kind of energy or like power you want to measure and implement it in the MyPV cloud for monitoring, but you do not need this device for the Soltor. The Wi-Fi meter is actually made just to measure how many surplus power do I have right now when you want to use here an AC Tor or an AC Elva 2 for the classical surplus heating we do. So we are always using just as much surplus we're having at the moment.
I've got a bit of a technical question here. See how we go with this. The way that you divert energy when it's AC into a heating element, is it using pulse width modulation, or is it using sort of on-off pulses?
Yes, it's a pulsed DC power, which is being used for the immersion heater then.
Right. So that provides a very clean sinusoidal waveform. It's not a noisy device electrically. You might not realize this, but in Australia, there's no rules around what type of waveform. So
Okay.
some diverters use what's known as burst fire, like two full cycles, then a pause, two full cycles, then a pause, which is terrible for flicker and harmonics.
Yes, I guess it's more strict here in Austria.
Yep. I think that might come to be a requirement here as well as we get more and more sort of hot water diverters that use, noisy systems like burst fire. Cool. Now, I've got another question here. You might not know this, but we're having a bit of a battery revolution in Australia at the moment. The Australian government announced a very, very generous rebate program for batteries up to 50 kilowatt hours. And the uptake has been incredible, like over 100,000 batteries installed in the last few months. But if you've got a battery system, how does that interact? Like, is it a benefit still to have a Solthor system as well? Or should you just try to charge batteries?
Of course, batteries are always nice because then you have electrical power. What we have here is, I would say, just warm water. Um, the benefit I see here in combination with batteries is when you use AC for backup, then it's always good to not pull this AC power from the grid. You can also pull it from the battery then. Yeah. So even though you have not enough PV power right now, but you have still power in the battery, then you can use it for backup power for heating as well.
Yeah, so I guess having a DC mechanism for heating water takes that load off your backup circuit. So your AC backup isn't wasting its battery energy heating water when you can heat it directly with solar via DC. Yeah, I get it. I'm just thinking of other benefits too, is that considering the average domestic home in Australia uses about 15 kilowatt hours a day to heat water, and if that tank has a standard resistive element that you can divert power to, you've effectively turned your hot water service into a 15 kilowatt hour battery in inverted commas, because you're storing energy.
Yes. Also, you're just increasing the storage capacity of the household. That's how we see that. Yeah, you have maybe like 50 kilowatts in a battery and 20 kilowatt hours as well in the warm water tank. Yeah.
Yeah, and
Then
I
you
imagine that solution is much cheaper than buying a 20 kilowatt hour battery.
yeah,
Cool.
that's for sure.
What about if you're doing, say, a larger project, like say a building with multiple dwellings or a large heating requirement? Can this system be scaled?
Yes, actually, all these systems are completely independent from each other, and of course, you can scale it up. Yeah.
Right. So here you're showing 6 units. They are are they AC Thors or Sol Thors?
These are Soltors.
Right. Oh, yeah. Okay. I just read the slide.
Yes, yes,
Okay.
right.
So 1 per tank. And yeah, so you got 6 apartments, 6 Sol Thors, 6 strings coming off the roof. You've also got AC backup from 6 different energy
Yeah.
meters by the look of it.
I mean, in
Oh, no,
this
just from
case here,
one.
the Soltor is the only. No, how is it called? There is no other heating source in these boilers than the Soltor, so it's definitely making sense to back up by AC just to make sure that you always are comfortable with warm water. Yeah.
I think I understand it now. So the thick grey line is the AC supply, and that also goes to each of the tanks as a backup.
Yeah.
Got it. All right. So it can scale. And if you're trying to monitor these as a whole, can they be aggregated? Like, are you looking at 6 different cloud-based connections, or they appear as one in the cloud?
No, they appearing separately.
Separately. Okay. I just thought with RS-485 you might chain them all together to be like a master
Yeah,
and
it's a good
slaves.
idea actually. I need to check it. We can connect the AC Tor up to 11 devices for in the multi mode, but I need to check how we can maybe connect the Sol Tors as well for, as you said, bigger applications. Yeah, I think right now it's really just separately shown in the cloud.
Right. Now, for customers wanting to retrofit a Solthor to an existing hot water service, what do they need to consider?
Actually, they consider the maximum power of the immersion heater or of the heating element. And usually in these applications here, there should be a thermostat, like a bi-metal thermostat, and that's it. Yeah.
Do they have to change if they've got, so as you might be well aware, in Australia, a 3.8 kilowatt immersion heater is pretty standard. Do they have to change that immersion heater for the DC heating?
To be honest, I'm not sure. Officially, yes, I would say yes, but I need to ask if we can make here some tests. I mean, I'm sure there is some safety left for more power, but I cannot say officially here, yes, you can use a 3.8 kilowatt immersion heaters. That would not be fine. No.
Right, because I'm just thinking about the over temperature switch that's a mandatory requirement on immersion heaters that's built into the immersion heater itself. If you're passing DC through it and it opens, won't you be getting arcing at the contacts when it opens?
Yeah, that's why we need to pulse the DC power we're giving to the elements.
Oh, I see. So it can switch
Yeah.
easily. Right. So it's
Right.
not a constant DC current that.
Yes. Otherwise, it's would not work with these normal switches, as you said. Yeah.
All right. I think you've solved all the problems there.
Yeah.
Yeah. Oh, that's pretty cool.
So yeah, that's what can happen when you just switch off DC connections by AC switches. Yeah, that's not what we want to have.
Yeah. Yeah. We've had plenty of problems in Australia with failure of even DC switches on roofs because of lots of factors. So yeah, DC is very challenging when it comes to switching.
Yeah.
So it's a clever approach is to pulse the DC so that it's easy to switch. It's going through 0 volts. What frequency are those pulses at?
I don't know.
Okay, that's right. Sorry,
Yes.
I know that you're a product manager, maybe not the R&D person.
Yeah. I mean, I can get you that information, I guess, but I don't know. I'm not sure.
Yeah. Now, in terms of having the product suitable for Australia, do you plan on getting it certified for the Australian market?
Yes. So there are already running some tests as well, and there is quite some projects over there. And a certification is one of the next steps we want to make here. Yeah.
Oh, great. Well, David, I've really enjoyed learning more about the Sol Thor. I've loved the AC Thor, and I think you've taken the best of the AC Thor and made it better with the Sol Thor. It's certainly a big step up from the SC20 days with kind of just your little box on top of the tank sort of solution. This is great. The IP54, the fact that it's got 26 amp input current rating, that it's got such a wide MPPT range, and it can run up to 3.6 kilowatts. All of those things are really, really excellent. I'm just curious, as a product manager, do you have some other exciting things on the roadmap that might be coming, or is you keeping that?
Sure.
Yeah.
Keep up for 2026. Yeah.
Yeah. Can you tell us, or we have to wait?
I will not. I will not tell very much, but it also has to do with this dynamical tariffs as well, because it's a good thing. Actually, you can help the grid, and you can help yourself when you're using these kind of tariffs. And yeah, we are seeing here a growth to that direction, because then everybody actually can help the grid, and it's not necessary to have such a strong infrastructure, grid structure, when we are just having a good timing when we are consuming energy.
Yeah, use energy in the smartest way. Yeah, I like it. Well, David, I think I'll wind things up now, and I'll send you back to the weight room while I just farewell my viewers. Thanks very much.
Yeah, thank you very much for inviting, and it was a real pleasure. So maybe we can see each other in Australia one day. Would be fun.
I hope so. Okay, well, hang around in the weight room, and I'll be back to you once we've stopped.
Bye-bye. Thank you.
Yeah, well, some fantastic insights there from David, understanding the features from MyPV. I should point out there's a whole range of products on their website. It's my-pv.com, pretty simple name, my-pv.com. So, yeah, I suggest you check out their website. I'll put a link in the description. And really excited to hear that the Solthor is coming to Australia. Anyway, till next week, that's all for today. But thanks everyone for watching. And till next time, check it.